In this video, we'll be looking at question number 33 from 2020 Standard Maths exam. This question came from non-linear relationships, and specifically it was from exponential equations. And this was, you expect them to be a bit complicated. So it lived up to its expectation, but nothing too bad compared to anything that we have seen in the past. So what we have here is you're given a graph. As soon as you look at it, you should be able to tell that this is an exponential graph. That's one of the properties. This is how it looks. Then what it's asking you is to calculate what are the number of bacteria at 40 minutes. It's very straightforward. All you need to do is go here, look at the value, what is at 40, which is 4,000. 4,000 would be your answer. So that's pretty straightforward. Then the next part is a bit interesting. What it's saying is that this is the equation with which you can model the bacteria growth, and it's asking you to use guess and check method to find the upper and lower estimate for the value of P. Let's take this out first. If the question here, you're not even given A, and it's asking you to calculate the value of P, but what implied is, and if you know the properties well of exponential equation, that the starting point is the value of A. So this A would be 1000. So the equation actually is 1000. You already know this. A is 1000 times B to the power of n. N would be the time in minutes. So all you need to now do is find the value of B, and they're not asking you to exactly find the value of B. All they're asking is to use some guess and check to determine where B would lie. So if we take one value here, for example, this point, data point, n is 20 and y is 2000. So let's plug this in. You can take any point from here, the answer is not going to change, times b to the power of 20, sorry, 20. So n is 20, y is 2000. So just simplify it a bit, 2 is equal to b to the power of 20. Now we can't solve it as it is, that's why they're asking us to use trial and error. So you play with a few values, and one thing again that you need to know when you're playing with the values is that because the shape of the graph is going up like this, the value of b has to be greater than 1. This is one of the properties of exponential. If the shape of the graph was going like this, down, like coming from here like this, then the value would have been less than 1. So because we know that the value is greater than 1, start plugging in a few values. And they're saying to differ them by 0.01. So you can start playing with 1.01, 1.02, 1.03, and so on. So I plugged in a few values. What we end up getting is that 2 is equal to the values that bring us close to this answer is 1.03 to the power of 20. So forget this 2, 1.03 if I use to the power of 20, this would bring us to 1.81, and if I use 1.04 to the power of 20, that would bring me to 2.2. So this 2 lies somewhere in between these values. So B has to be somewhere in between 1.03 and 1.04, and that's your answer.